Welcome to our keynote on Kata. If you're wondering what katas are or what a kata is, what for it is, what it's for?
What it's for? Well, if you take one thing out of this session, then please memorize this meme. It says katas let you internalize basic steps, so you will use them subconsciously while programming. And that's all about. Now we are ready? We're done? Finished?
Okay.
No? No, not really. We have to explain this, I think.
We want to see the karate.
Yeah. We have a karateka here.
But don't be afraid, we don't do the karate.
So, katas are basically about, learning, and a special way of learning by repetition. So, learning by repetition is a well-known concept. And, you see this guy. This is not what we mean by learning by repetition. What we mean is doing the same thing over and over again, so you will be better each time you practice it, until you master that thing. That's the basic concept of a kata. And there are different things you can practice. So, for example, have you ever played a guitar or an instrument? Well, I hated my first steps when I began this. So when you want to make a sound on a guitar, you have to pluck those strings here. Okay, sure, obviously, and it should sound differently. So you want to make a note. So you hit in this bar. There are different bars, and you hit this string, and then you can make another sound. You won't hear a sound. It's a silent guitar. So yeah. So, but the idea is clear, right? So, if you want to have, different sounds, other sounds, you not only have to hit one string, you have to hit several strings. So, for example, this is a G chord, okay? See my finger pattern here? Yeah. Well, when you start this, it's very, very stressful, because you have to remember, I have to put this finger here, and I have to put this finger here, and then I somehow manage to put my index finger here, and then you have a cramp, okay? So that's how you start playing the guitar, basically, with lots of cramps in your left hand, okay? So, and now, when you practice this over and over again, thousands of times, then you're actually able to do this in one single stroke with no problem. You always hit it, okay? I don't have to look. No, I have to. But basically I don't have to, okay? So it's memorized. Okay? So that's one part where you can practice all over again, and you really do that all the time when you play guitar.
And then actually people want to listen to you.
Yeah, that's why I brought a silent guitar. They don't, so
they don't have to listen to you.
Right. So another thing where you practice all the time is dancing. You know how you can.
Which he did a lot. You did a lot of practicing.
Yeah, I did this with my wife.
I did only very little, because I'm not a good dancer.
Yeah. Oh, we can. So you know the difference between an extrovert programmer and an introvert programmer?
Yes, of course I know.
So what is it?
I'm the one who's looking. I'm the introvert. I'm looking at my own shoes.
Yeah, right. And the extrovert is looking on the other guy's shoes when we're talking to each other, right?
Yes.
So and with dancing it's the same basically. Well, it's like. Can I have your please? Can we do this? Okay, we haven't practiced this. This one. You're the wife. Yeah. Okay.
No.
Yeah, you're the girl, so I'm the man, I'm leading. So and this is slow waltz, okay? Okay, so you have to do this one back, okay, this one, yeah, and then this, and then this.
What?
And close it. Yeah,
okay.
Yeah, right. And one, two, no, the other one. And 1, 2, 3, 1, 2, 3.
I think
you're really thinking about it, right?
You really have to practice this more. But I don't want to practice it with you.
So you see the difference. When you start doing this, you're actually looking on your shoes, and you have to think about this, and you have to think really hard, and you can't talk to the other one. So dancing is some kind of conversational. Yeah, you want to discuss things, for example. You want to have a nice chat, something like that. You want to talk to others, and you want to dance, okay, in a smooth way. But in the beginning, you can't do that, because you have to think about every step, literally every step. You have to think, okay, now I have to do this, and then this, and then this, and then I have to, oh, no, the other one, oh, sorry, I'm sorry, your shoes, oh, they're dirty now, oh, sorry, okay, goes over and over. And the idea is actually to make this a subconscious act, okay? To practice this all over again, and soon you will getting better and better, and you don't have to think about every move, what you want to do, and you can master this stuff. That's the idea. So, and another exercise or another discipline where katas comes to mind is martial arts. Actually, the origins of kata is in martial arts. It's a Japanese term, and it means form. And actually, a kata is a, well, I let this Benno explain. He's better in this. So, yeah, would you introduce Benno?
Well, we actually got another slide which shows a single kata. I think it's the first kata in Shotokan karate people learn, but as Bernd already said, we are very happy to have Benno here with us today. He is practicing karate for 35 years now. He holds the 5th dan, which is the 5th black belt. You may know that there are those student belts, the colorful, and the black, which are the master belts. And he will tell you something about the origins, so where katas come from, and will show you something. He will talk in German, but even if you don't understand German, I think it will be impressive, and you will understand what he will show to you. Okay.
Ja, guten Tag, meine Damen und Herren. Ich zeige Ihnen heute eine Kata aus dem traditionellen japanischen Shotokan-Stil. Die Kata nennt sich Teki Nidan. Teki bedeutet übersetzt der eiserne Reiter. Werden Sie an den Stellungen erkennen. Ich zeige es Ihnen erstmal langsam, damit Sie die Bewegungen einigermaßen erkennen. Und dann nochmal schnell, wie sie eigentlich ausgeführt wird. Dankeschön. Nun, Teki Nidan, der eiserne Reiter. Nidan, die zweite Stufe. Übersetzen? Gut. Zeichnet sich durch zwei Blöcke aus. Sie haben es gesehen am Anfang, die Arme hoch, was im Endeffekt eine Befreiung aus einer Umklammerung von hinten ist. Dann die zwei Seitwärtsteile, die sich mehr mit dem Gegner nach vorne beschäftigen. Bedeutet, die Kata ist nicht nur vollkommen sinnfrei im Raum, sondern sie beschäftigt sich in Gedanken mit einem Gegner, mit bestimmten Angriffen in bestimmte Richtungen, die aber zum Schluss in einer optimalen Ausführung gemacht werden sollen. Das heißt, die Techniken, wie sie gemacht werden, mit welchen Spannungsverläufen, Sie haben es gesehen bei der schnelleren Vorführung, dass dort langsame Teile dabei sind, dass dort schnelle Teile dabei sind. Die haben alle festgelegte Rhythmen, festgelegte Zeiten. Da soll ein bisschen Ausdruck dabei sein, sodass über die Zeitdauer des Lernens diese Techniken immer und immer wieder optimiert werden und nach einem möglichst optimalen Stand gemacht werden.
Okay. Thank you very much, Benno.
Danke.
Cool.
Awesome.
Danke. I still have goose pimples.
This is so impressive. In our company, we have a karateka who is second dan. So I saw him several times do a kata, and I was already impressed because just the physical presence is, I think that's just awesome, standing there and thinking, wow. And Benno, it's for me, it's even more impressive what he just did.
Yeah.
Okay.
Benno, for how long were you practicing this? 35 years. 35? Oh, awesome. Okay. So just
you're too old. Okay. I'm sorry.
Yeah.
You
I could start. So I would be 70
yes.
then. Okay, never mind. Okay.
Okay. This isn't really a karate conference. We are more talking about programming here, software development. So how do katas fit in there? Katas were introduced to programming by the pragmatic programmers some years ago. They brought the idea from the martial arts to programming, and it got really popular, I think, 2 or 3 years ago with the Softwarecraftsmanship movement. They introduced katas, especially at code retreats, to own your programming skills. Benno just talked about that the kata in karate actually symbolizes some moves. Or it symbolizes a fight against an opponent, against an imaginary opponent, which isn't actually there, but you practice the moves, such as he was there, such as there was an opponent. In programming, we don't really fight against an opponent. I think, yeah, sometimes we think the customers or our bosses, the PO also, is our opponent, but usually we don't hit them. So I hope you don't. I never did. So what we really struggle with in programming are some tasks, some problems we try to tackle. And so the starting point for a coding kata is some small focused task, some small focused problem we're choosing. Often we choose some algorithmic problems, such as decoding Roman numbers or doing a Caesar cipher, doing a prime factorization, something like this. We'll show an example for this shortly. And it should be small because you want to practice it over and over again. So it should be something you can solve in about 15 minutes, maybe 30 minutes. That's some small focused tasks. And when solving the problem, you will find a solution, but the solution isn't in a kata what is really the main focus, what's the most important part. The most important part is how you actually come to the solution, which path you choose. And maybe when you're doing the kata again and again, you may take some different paths to explore some different paths. This is a variation to the karate kata, where it's a very fixed form. But in programming, it's part of the exercise that you actually learn to walk different paths to solve the task. And I already said it, that you're doing a kata again and again, and Benno also talked about how often he did the same kata, and so a single run is only a small snapshot. It's not enough to solve the problem once, but you're doing it not at one time, but over the time you're solving the same task again and again to own your skills in solving that problem. Not actually solving that problem, but to own your programming skills at large. So, Bernd, why do we actually do katas?
Well, here's the thing. This is the, in English it's a hard thing to say, Pythagorean theorem. You know that? Well, a squared plus b squared is c squared. It's very simple. You learn that in, what, 5th grade, 6th grade, 7th grade, I don't know, somewhere there. Okay? So very simple. Actually, there are over 300 proofs for this simple sentence in several disciplines. Algebra, trigonometry, number theory, and so on. Okay? Over 300. So the result is always the same. It's a proof that a squared is b squared plus b squared is c squared. That's it. But the way is always different in all the 300 proofs. So the idea with katas is not to have, well, the best result. The idea with a programming kata is more like exploring different ways, and actually, well, you can make this on a broader level. So for example, you can use different languages, something like that. And then you can settle for one solution and you can refine it in detail over and over again. However, the way will always change. You will make the same exercise over and over again and never do it twice the same. Almost never. That's the idea. So the idea why you should do this is, well, you learn several ways you haven't seen before doing this. In normal programming, you only most of the time use one way, the one you know, you think is the best. And if you succeed, if you write tests at all and they are green, then you're happy and you're done. The idea with a kata is, well, actually to have a tool for self-reflection. Where can I improve? Where can I master this thing? Benno did it for 35 years, and he is a master. Truly he is. Sure. But have you ever seen a programming master? Well, there are actually not so much. You're actually, well, you can be announced as a master if you have a good solution, one solution for a problem. But that's not the idea here. The thing is, can you use your tools like a master would? And that's the idea with the kata. Okay. Usually, you use katas in isolation and with constraints. Let me explain. Isolation means that you don't use katas, or you are not working in katas on, for example, legacy code, which is code which is already there. Okay? There are some refactoring katas, but they are special. Usually you have an algorithm and you just code this algorithm. And you have a very, very clear environment. You don't have any dependencies. You want to focus on the problem, on the way to solve this algorithm. That means the isolation part, and the constraints are, well, you can have different skill booster, let's call them that. You can use, for example, different languages. So the kata is totally different when you do it in Java or in JavaScript, or as you will see in CoffeeScript. It's different. Of course it is. Yeah? But the solution is always the same. You will solve the algorithm. Okay? So another constraint could be, well, what could it be? Have you an idea?
Don't use the mouse.
Yes. Oh, only the keyboard. That's a good one. Have you ever done that?
If you want to own your keyboard skills, use a lot of shortcuts, and
yes.
Yeah. You actually get faster doing this.
Yeah. So and it's amazing how only few people, only few programmers I know can do everything with keyboard and don't use a mouse anymore. They actually improve their coding skills with avoiding the mouse. You can do it as a game while pair programming. Every time you touch the mouse, you get a bump from your partner, something like that. Okay, that's an idea. Okay, so that's one constraint. You can.
Another would be like don't write methods that are longer than 2 lines.
Yeah.
So you really
in
have
Java, 2 lines in Java.
So you have to have really focused small methods that do only one thing and don't have those like 80 or 180 line methods.
So, and for example, you can, if you want to practice a pattern, a coding pattern, a design pattern or something like that, you could say, well, I want to do this algorithm with this pattern. If it makes sense or not, doesn't matter. Okay? Just try to get to the point of this pattern. Yeah? That could be another constraint. And so on. There are dozens of constraints if you are not challenged enough with the kata already. Okay? So, the question is still why you should do this. Well, there's one thing which is called muscle memorization. It's not really a scientific thing. It's more like a, well, it's a model how this could be, well, interpreted, what we are doing. The thing is that that your muscles have kind of a memory, and the longer you practice something, the more this memory will be trained, so that you actually can do something unconsciously and don't have to think about this. Okay? That's what I told you with the guitar, for example. And the idea of muscle memorization means, well, in programming, you have a muscle memorization for shortcuts you use. For example, refactoring without shortcuts is pain in the ass, really.
Well, it depends. It depends on the language. You're still living in Java land, don't you?
Yeah, sorry.
Yeah.
But still,
there are actually better languages today.
Even in a functional language, and you don't have a support of an integrated development environment. Even then, especially you use a lot of shortcuts in your simple text editor.
Yeah, I'm just using a very plain editor nowadays.
Yeah, and that's good. And you're using the shortcuts,
of course.
Yeah. So, and you're not thinking about this. You only think, well, I want to have this segment of code. I want to have it there, and ta-da. You make it. You don't. Well, actually, when we pair program, I remember times when when you ask me which shortcut do you use, and I have to think about it. Well, okay, I put my just a moment. Let me try this. Yeah, that's it. And then I can show. I
know this. I'm watching my own fingers what I'm doing because I don't know the combination. I just do it.
So, and the same thing you want to do on a higher level. You can make the challenge even harder. You don't want to think about, well, how can I make this class disappear? How can I refactor it into 3 classes, for example? You don't want to think about this. You don't want to think about every step. You know the book by Martin Fowler? He explains every single step you have to do when you don't use automatic refactorings. And you don't want to think about every single step you have to do to make a refactoring happen. The idea is actually muscle memorization. You just say, well, I want to have here 3 classes instead of 1, and ta-da, it's done in seconds. That's the idea.
I think we talked enough now.
Yes. Coding.
Let's get to something more practical. I mean, you still have to talk, but...
You're talking while you're coding.
I'm talking a little bit. What we are showing you now is... Where is it? I'm showing you a kata I practiced for some time now, and the problem is to decode Roman numbers. You probably all know Roman numbers at least a little bit. That's where the D is for 500 and the I is 1, and you sum up all the letters. I'm using CoffeeScript as a language. I'm using Jasmine. No, what's it called?
I think Jasmine.
Jasmine, okay. Jasmine as my testing framework. And I'm using a little tool from codersdojo.com, which does run my tests all the time. So I don't have to switch back and forth. I just save my code in the editor, and it saves. It runs the tests. It shows me, Jasmine shows me whether everything is green. And Coders Dojo actually records all my steps, so I can look later what I did at what moment. A special focus for me in this kata is that I want to do a very strict test-driven approach. You also probably all heard about test-driven, or I hope most of you practice it, where you first write a test that shows you something is broken, something is missing. You have a red test. You implement to make the test green, and then you reflect on the code and see, well, how can this code be refined? How can we refactor the code to make it more clean, to make it more expressful? And we thought it would be too boring if you just have to look at me coding here for some minutes. And so I will actually be your code monkey here, but to show you, to talk about what we actually, or what I'm actually doing, it's like I open up my skull and have 3 voices inside of me, and those are I'm doing a little bit of talking myself for my own, and Sebastian is the one who always wants that everything's okay. He says, make it run, make it green. Bernd is the clean code guy.
And he's not the naked guy. He's
well, I'm actually the programmer. I'm the one who does the actual work, and the other guys keep telling me I just break everything. But well, that's necessary sometimes. So,
okay, let's start. Which state are we in? Does the test run?
You're bugging me already.
I think it's quite clean.
Okay. I'm starting off with a clean slate here, no files yet. I'm setting up my tool, this Coders Dojo thing, and on the left-hand side here, I'm then running my tests.
Ah, we're green, fine.
Yep. We're green.
Good.
Okay, we're no tests, we're no code yet. So
what you're actually doing is you're making the first test, right?
Yes.
Is that, yeah?
And I'm saying I expect Roman I to be 1.
Oh my god, oh my god, now we are red. I think we should do something.
But it's clean, it's okay.
The most obvious implementation.
Fake
it, please.
Totally clean. It's no, let it. It's
okay.
So
oh no,
much better.
That's
no.
Very simple, very faked implementation.
But it's not. It's totally.
Yeah, I want to just write a second test first.
Magic number redundancy.
Expect. Well, this looks also a little bit ugly. Like I repeat all the time here. Comes to
I have
5.
physical
it's red. I
pain.
think you should first.
Yes,
make it right.
I will first fake it and then I will make it clean.
Fake it? Did he say fake it?
Fake it till you make it.
What? No.
As long as it's green, it's okay. I'm feeling good. We can deliver this.
Straight
the
to hell. It's
okay.
Oh, come on.
Everything's running, but I really want to add the X here next, and well, this would get really ugly, so I'm refactoring this here.
Ah, that sounds good. What are you doing?
What is my editor doing down here? Okay.
Do whatever you want as long as it's green. I don't care.
So
well, it's green, but it's ugly. That's not the point. Ah, you're using an object, okay? And you're actually using that object now. And how does it make it? It's more complicated. Well, good job. Very good. And now it's...
Yeah, I'm building
a
new structure here that's actually the same.
That's the same structure. I see it. I can... Oh, that's clever. Oh, that's cool.
Good. So
that's really
cool. The code down here looks okay, but actually the tests, I don't want to write every test like this. So it computes single digits. This is what I really want to write, something like compute single for these Romans. Something like this is what I really want to have as a structure.
No, now it's broken.
Of course, this doesn't run.
If you don't know how to fix it, undo, please.
This doesn't run because we don't have this for these Romans yet. I have to write a little CoffeeScript method for this.
So I think it's okay for refactorings when you have a red test. You know that something's not right,
If
and
you know what
you want
you're
to
doing,
keep doing. So
small
refactoring in the test is with a red bar, and refactoring on the productive code is with a green bar.
only in short steps.
Yeah,
We are
of
still
course.
red.
Of
We
course.
can't deliver the software now.
Okay,
Ah, we agree.
everything's okay now. I want to see whether the test really bites. Yeah,
Oh,
if I
no.
break it, it also
Great.
goes
Kidding
red.
me.
So
Okay.
this actually is instead of this one. And now I'm doing the one for I. First I break it. Yeah, it's okay. And now we don't need this one anymore. Okay.
Oh, that's clean.
This
that's
looks
cool.
better.
That's
So-
really cool. Okay.
Now I can easily add the X. Yeah, this looks nice. And yeah, now it's boring. I just add the other one in a single rush.
Oh, isn't that exciting? What
No,
he's
it's
doing?
not
Huh?
exciting. It's red.
Great. What?
Maybe too big.
No, but
step.
he's but
Yeah.
he's making it clean and it's
Sure.
nice. The structure is great and
And
oh,
now
see,
I'm feeling
it's
better.
symmetric. It's isn't it?
Now that's better.
Okay, I think
That's
we
cool.
should get to something more interesting now, like computes, additive digits, so we can handle more than one. Like do an, I don't know, VI, which is, VI is 6, right? Yeah.
Oh
Should
my
be
god.
6.
Oh my god.
So the V is a 5 and the 6, yeah, and the I is that's okay. And how?
Okay.
Oh, come on!
No,
you
we wanna
showed
go-
such a good structure, and now you're breaking it all again.
so
what?
why not?
It's not broken, it
It's
runs.
A 6. What?
Who cares?
I mean,
Yeah, this is ugly, I know. But you
This
know,
is
I
a
can actually break
strange
this up
style.
step by step. The 5 is actually here the V, and
okay.
this one is actually the I. And the V is there because it's the first character of the VI. Oh, no, that's at.
Do whatever you want there, as long as it's green.
Oh, I'm green again. No
We call
problem.
it in Germany in Schönheit sterben.
Okay. And the VI is actually, which is the Roman string. So
That's impressive.
Okay.
You're actually solving
looks
this like a riddle,
now
right?
to push this
And
a little bit
why
further.
aren't you continuing? It's length. Okay.
Yeah.
Okay.
Okay.
So you needed a new test for a motivation to change. Okay.
Yeah,
I see
yeah,
that. Yeah, it's okay.
And now to push it a little further, I'm using now something we can handle 2 digits. I want to be able to handle 3 digits now.
Okay.
Oh no, Roman string length is 3.
You're still red. You know what you're doing there?
Yeah.
Are you
Everything's okay,
keep
isn't
doing
it?
this forever now? Or it's not leading to something, is it?
I want to see where this leads me, and then okay, this. Now
I mean, you
I'm-
can take the 17 after that and make a 10 plus 5 plus 1 plus 1 and so on. It's not.
That's
Well,
serious.
that would be a stupid idea, wouldn't it? And I don't do stupid things, do I?
Okay. So as long did I get this right? As long as you don't see the structure, you keep going
So
until you see it, right?
Now I see I have here a similar structure to here, and actually down here, I can say this is also, see that now this is a similar structure. These are actually loops, so I want to turn this into a loop step by step.
How? I mean,
you're
it's
running-
green,
Yeah.
yes, but
Yeah, I'm unfolding manually loop step by step. I know. But I'm getting there little step by little step, and so I'm staying
I
on
don't
the green
see it.
path.
oh yeah, another structure. Why not switch case and
Oops,
you
sorry.
could make another class and a hierarchy of classes and
Bernd?
Yeah,
You
yeah.
usually aren't ironic. Why aren't you ironic? Are you angry now?
yeah, I'm frustrated.
Okay. So
Why
now
are
I can
you-
take the second line in here in the loop, and I can
that's
take
clever.
the third line in the loop, and now
that's
now I
yeah.
built a
Okay,
complete
I'm
loop.
sorry.
And the 3 here is actually, well, I tested it up there. It's the Roman string length. Okay,
Oh, that's cool.
this looks okay now.
That's cool. That's
And now I
But-
can actually weaken the. Oh
No,
no!
you can't.
Ah. Yeah.
Okay.
Now I can weaken this one to include the 2, and so I don't need this one down here anymore. And I can take this line in here, and I don't actually need the condition anymore.
Whoa, 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 whoa. Okay. Can you repeat this, please? It was much too fast for me.
I will show you another time.
Okay. Did you get that? It's amazing, isn't it?
Okay.
So the test ran all the time. It was all the time green. That was
All
the
the
most
time?
impressive part.
Now I'm iterating
Okay.
over actually all the characters. I can do this also a little bit easier just by splitting my string on every character, and I don't have to look the characters up manually. No,
It's not split.
It's splitter. No, it's split. And I'm making this a little bit more CoffeeScripty by putting the sum up here in front of the for.
More
Not doing a classical for loop.
CoffeeScriptly. Okay.
Never heard
Well,
that.
in my opinion, that's more CoffeeScript style. But
If you think so.
okay, I think we should.
It's clean. Okay.
Yeah, we should get it a little bit on here. And what's interesting now are the subtractive digits.
Oh, that's tricky, right? I mean, so
So-
XL is actually an L is 50
So
and X
that's-
is
yeah,
10, and because the X is before the
It's
L,
40, so
it's
we're
40.
actually here 20 off with our, we get
Well,
back the 60 instead of the 40,
so you sum everything. So yeah, of course it must be 60. Yeah.
Obvious.
Magic numbers. Yeah. Why am I not surprised?
So, just take 20 away and everything's fine.
But I'm cool now.
The,
I'm cool.
the 20 isn't there by accident, because we accidentally added the 10 instead of subtracting it, and so this is just 2 times the 10 that we're subtracting here again. And the 10, well, that's the x. And the x is, of course, the first character of the XL back here.
Of course it is. Yeah.
Okay. And, well, this doesn't work for the XL, but it doesn't work if we're just having the XL somewhere in the string, because we are testing for equality back here. And, well, I'm misusing regular expressions a little bit by saying if we have this as a substring, everything's okay.
So you're actually grabbing the subtraction out of the string.
Yeah.
Okay. And then you
So-
pull the first
Oh.
character.
Sorry, you got questions?
The first, just trying to get this. You're
Yeah.
pulling the first
You
character,
can watch it later.
and then okay.
at
No, I'm
the
just.
right,
No, it's okay.
At the
it's
right
okay.
speed for you.
It's not really clean, is it? It's. I mean, it's.
It's green. What
Well,
else
yeah,
but-
matters?
I'm using now a different subtraction to see. Well, this time we're 2 off, and now I'm trying to refactor the step by step to have a similar structure. I can take a little bit larger steps now again, because I already know
Okay.
where this leads me.
So it's
Okay.
it's again you're
Oh, I
building
really
the
have
same
to-
structure to
Yeah.
see a pattern in it. Okay,
Now I
I get
have-
this. Yeah.
And I'm extracting the XL now out of it to have really the same line in
Okay.
both cases.
That's
Okay.
more dry. So
This-
dry. Don't repeat
this
yourself.
works.
Yeah. So. Okay.
And I'm doing the same down here.
It's interesting how you have to load the
subtraction.
code to actually make it.
To make
Make
it
it more
implode
clean.
again.
So.
Okay, now we really have the same line here, just using a different variable, one time XL, one time IV, and this screams for another loop. So we can just go over an array and put those things in there. Starting first with just 1, with the IV, and then I'm saying, okay, for every S in my subtractions.
I'm feeling uncomfortable again. It's
Why do you?
because of all the structure.
Yeah, but see, now I can just replace this one.
Okay.
Now I can replace this one.
Okay.
Oh, now I'm switching to another workspace, and now I don't need this anymore. And
Okay.
now I can just extend the array up here and it breaks everything. And when I'm removing this, it runs.
So actually what you're doing now with the list is the same you did with the object before. The digits and subtractions are better structures to have a more maintainable code, right?
Yeah. So, and actually I'm pushing the if up here, making when for s and subtraction, when Roman string matches s, then I'm subtracting this. Okay, I think the code looks pretty nice already. We're missing some of the subtractions here. And I actually forgot my cheat sheet, but I think I will get them together now. Okay, this is 444, and the other subtractions there are in Roman numbers are is a 999.
So actually, you think you are more secure and you take bigger steps, right?
Yes,
that's
yes,
the idea.
yes.
Okay.
Because I just have to add here some little things, and I can handle this within a few seconds. That's what is it called? 10 seconds.
That sounds like, looks like very clean code.
Okay, so I think this is my finished algorithm. These are my tests. Actually, this tests seem to have some duplication, like we have the 4 here and the 4 here, so I'm just removing this one.
Oh, I
and
didn't
this
see that.
line looks a little bit different. I want to have clean regression tests too, so I'm saying computes mixes of additive and subtractive digits.
I like how you keep
And
your test code clean as the productive code.
I move this one down here. I see, okay, everything went okay with the new test. Good. So the tests look okay for me now. The code looks okay. I think we can finish this.
Cool.
And everything's gone.
Great. Thank you very much.
Okay. Okay. How much time have we left? 18
About
minutes?
70 minutes, yeah.
That's okay. As you might imagine, I didn't do this the first time this way. I actually practiced. I first started this this kata with JavaScript. I did it with JavaScript about 50 times or so. I was slower at the beginning, but then I get faster. I took different paths. I tried different solutions, and well, lately I switched to CoffeeScript and to Jasmine to learn that better and to learn how I can do TDD with that and to try some TDD things with it. What should you pay attention to when practicing a coding kata? First thing, take some time. You don't have to have a lot of time for doing katas. As I said, you should be able to solve it in 15 to 30 minutes. So you don't have to take a day off for it. But you should do it, you should repeat doing the kata. And so it's good to reserve some time where you can again and again practice your kata. Maybe think about going to the office every other day, 15 minutes earlier, and starting the day off with practicing a kata. Or maybe meet with some colleagues every Monday after lunch, and everybody does a kata then. Take a little time for practicing katas. And then repeat and repeat and repeat it over again. This does really feel strange when you do it the first time. Oh no, when you do it the second time actually, because the first time it's just that you're solving a solution and it's okay, that's what you're used to, and then you throw the code away, and the other day you're looking at the same solution, the same problem again, and thinking, hey, I've got the solution in my head. It's stupid to just solve it again, but do it anyway. And you will see the second time you reflect on what you're doing, and you will do things differently, and you will do things differently the next time again. So you will improve, you will own the way you're solving this problem, and you will especially get better in, not just in this problem, but in certain aspects of programming. Like when I did this kata, I tried several different approaches which test cases I use. And I learned a lot about how a different order and different test cases that I use lead me to different solutions, or lead me easier to solutions, or which are harder to find a good solution. Seek feedback on the path you take. Seek feedback from others, like let others watch you, maybe record your kata. I told you Coding Dojo is a tool to record the steps, but just take snapshots. I also did a lot of screencasts. I recorded just what I did on the screen and showed this to others. I also got feedback when publicly showing my kata what I could do different. And I was reflecting on it myself. After I did a kata, I thought, wow, what did good? What happened during this run? What did go well? What didn't go well? What do I want to different the next time? And I wrote down what I wanted to do different the next time, so I'd actually remember and do it. And actually do something different the next time. Try some alternatives. And what I experienced is, as I told you, I did this kata in JavaScript about 50 times, and in the beginning I was trying very different ways to see, well, where does this one lead me, where does this one lead me, and I was trying very different things, but with the time I was more finding the one way that I wanted to choose to solve this problem. And so the variations got smaller and smaller and smaller, and until lately I actually switched the language, and this of course was a big distraction and threw me a little bit off track and let me try a very new way again. This is make it work, make it right, make it fast. I think you all know this from everyday programming, that make it fast is only the last aspect. This is also holds true for katas too. The first thing is you want to really have a solution, and then you want to have a really clean solution where you think, well, this is a really good way to solve this problem. And then at the end it's also nice to become faster and faster with the time. But this isn't the main focus of a kata. This is just a byproduct you reach. Code retreats is something with who of you has been to a code retreat? Okay,
1, 2,
very. No, I see 3 or 4,
5.
Code retreats are something different that really expanded during the last 2 or 3 years from the software craftsmanship movement. The idea is, if you're just practicing your programming alone, well, it happens that you get off track, that you really have to do your everyday programming. And code retreats are the idea that you're owning the craft together, and you're taking a full day off together with other professionals. And at many code retreats there are really great programmers, and doing a full day of intensive practice. And code retreats, you're usually doing the same problem that is game of life. There are some other code retreats like a test automation or legacy code retreat, but most of them are around game of life, where you're practicing with different pairs, so you can practice with different people to solve this problem. And it has a little Kata feel to it, but it's also a little bit different. All the slides with all the links are on. Up there is the link. Is good. Can Kata? Oh, the battery is off. And there you will also on is good. Can Kata? This is where you can find the slides. This is also a list of a few more links where you will find instructions, ideas on how to do Coding-Katas. Especially behind most of those links are small problems that that you can use as a starting point for your. Oh, thanks. That you can use as a starting point for your katas.
Yes, December the 8th is a Saturday.
Is it Saturday?
Yes.
Oh, okay.
So everything's fine.
So I looked wrong. Oops. Okay. Good. So again, you'll find the slides on is good can Kata, and this is back to our first slide, and I hope you now got an idea what this meme of this talk means. Katas let you internalize basic steps, so we'll use them subconsciously while programming. So, just like in karate, a kata isn't a real fight. You also, of course, you have to do your everyday work, and you also learn something during your everyday work. But to really own your skills, it is very precious to have a reserved space where you just practice those things that happen, that just rush by during your everyday work. And this is where katas come in. This is where katas help you, where they, as we say, let you internalize those basic steps that just happen to flow, that you don't think anymore because you just feel them, you just do them. And then you will use them during your everyday work, so you're just getting a better flow in your programming. I would like to invite you today not only to listen to this stuff, but actually to start doing a kata today here. We got, because this is called Can You Kata, not Can We Kata. Question is about you. And as an example, I got 3 problems here that you may start with. These are 3 typical problems that you may handle, that you may tackle when doing a kata. And I just will present them shortly. On the upper left is prime factorization, split an integer into its prime factors. Okay, so 4 has to be split into 2, 42 has to be split in 2, 3, and 7. What most people do with Coding-Katas is that they will combine it with TDD, because it really helps you to get into this flow when you're doing TDD to solve those problems. Another example is the test manager on the upper right. Mutate every word, so the first and last character stays the same, and the inner characters are in reversed order. You may have heard that we are actually capable of reading text when the inner letters are munched, when they are maybe in random order, if just the first and the last character is correct. And This is doing this.
Do the text manager with Java. That's a constraint. And don't use any external libraries. And oh boy, yeah.
This is pain-driven development, I think.
Yeah, definitely.
And the last idea is the string calculator, where you take a string, have several digits or have several numbers in it, and you add them up. They may be delimited by comma and new line, or you can specify a separator. So these are 3 ideas, and I would like to invite you to choose one of those ideas and do it today. Try to solve one of those ideas. You will also, when you go on Kata, there you have the slides, there you will have the problem on the last slides. And don't just do it for yourself. Maybe do it with someone else, so you can reflect with him together, or you show it to someone else, how you solve this problem. I also invite you to come to our booth. We are from it-agile. Our booth is behind the guard, behind the code check. And sadly, I won't be there because I have to look after my sick son, but Sebastian will be there, and 2 other colleagues will be there. Show them how you solved, which path you chose, and seek feedback from them. And also, if you want to have other hints, other ideas about katas, please talk to us.
Give us feedback. That's really important. So we mean it with feedback.
Okay. So, Bernd, any famous last words?
Thank you. Thank you for listening.
I have one last words, and it's a big thank you to Benno.
Benno, come on stage.
Lots of thanks to you.
Great.
To clarify that 5 days ago he didn't know what he was doing now. So thank you very much.
Okay, so come to us, talk to us, show us your katas, and especially do them. Thanks.
Thank you.